In this video, we will talk about route redistribution. Redistribution, guys, is the process of sharing routing information between different routing protocols. So it allows a router to inject routes learned from one routing protocol, for example OSPF, into another protocol like, for example, EIGRP, enabling the connectivity across diverse routing domains. So this is very much important if you need integrating networks that use different protocols and ensures comprehensive routing information across the entire network. Normally, without redistribution, guys, a topology you are seeing on the screen, which consists of EIGRP and OSPF domains, cannot communicate with each other. Okay, so to communicate these two routing domains to each other, we need to add redistribution definitions to the OSPF and the EIGRP routers. So redistribution operation involves some key steps. First of all, you need to import the routes. Like the routes learned from one routing protocol, for example OSPF, needs to be imported into the other router's routing table. Then these routes should be converted into a format suitable for the target routing protocol, for example the EIGRP. Then the converted routes needs to be advertised into the target routing protocols domain. So this process allows different routing protocols to exchange routing information and ensures seamless connectivity across various network segments. There is a term called seed metric in redistribution that is a method used to assign an initial metric value to routes being redistributed from one routing protocol into another. So this seed metric helps in determining the cost of the redistributed routes within the target routing protocol. It ensures that routes redistributed into the new protocol have a metric value assigned, allowing them to be properly evaluated and prioritized within that protocol's routing table. So when redistributing the routes, you can specify a metric to control how the routes are treated. So for example, you might use a high seed metric to ensure that redistributed routes are less preferred compared to the native routes. And seed metric value can be defined during redistribution configuration. Otherwise, the default values, as you are seeing on the screen, will be used. So how I am doing the configuration for redistribution? For example, in this example, you are seeing we have two different routing domains. The first one is the OSPF domain, and in the below I have the EIGRP domain. Pay attention, OSPF is using area 0 and EIGRP with autonomous system 10. Okay, so how I will define a redistribution so these routers can have the routes belonging to OSPF domain, and for example router 1, which is in OSPF domain, can have the routes within this EIGRP domain. So for this I need to go to the router 3, which is the border router between two different routing domains. Okay, so for example, in router 3, I am typing router OSPF 1 and I am going into the config mode. Then in OSPF mode, I am typing redistribute EIGRP and the AS number of the EIGRP, which is 10, as you are seeing in here. Then I am defining a metric to those routes, which is 50K and followed with the subnets keyword. Okay, what is this command doing? This command helps me to redistribute routes from EIGRP domain to OSPF domain. So it is within this direction, okay? by the help of this command set, router 1 will be able to see the routes coming from this EIGRP domain. Then I have a next step that I need to, because router 5 also needs to see the routes related to the OSPF array, right? I need to do a redistribution on this direction as well. For this, here is the command. I am going into the EIGRP mode this time, router EIGRP and the AS number. Then I am typing redistribute OSPF followed with process ID and the metric keyword, and I am typing a metric which is 1544 for this example. Then I need to define a reliability value followed with effective bandwidth, which is loading, and the MTU value. Okay, so the end result will be something like that. Redistribute OSPF1 metric. This is the metric value followed with the reliability value followed with the effective bandwidth, which is the loading, and followed with the this will be the delay, metric, delay, reliability, load, and the MTU. Okay, this is the command that we are using while we are doing the redistribution from OSPF network to the EIGRP domain. Okay, this is on this direction. So by the help of these command sets you are seeing in here, router 5 will be able to see the routes coming from the OSPF area 0. Okay, so if I just want to go ahead and verify this redistribution, very basic command I can use is just the show IP route. I am typing in router 1, so pay attention. Router 1 is the router which is in OSPF domain, right? So let's note it down. Router 1 is in OSPF domain. All right, so when I'm typing router 1 show IP route command, what I'm seeing, I am seeing some C routes, which means they are the connected ones already, which this router is aware of. I see O routes, which means they are the OSPF routes already coming from advertised from another peers. And I see something like O followed with E2. Oh my god, what is this? And I see multiple OE2 routes in here. If I have a look into the table, let me figure out where is E2. Yeah, it's here. So that means E2 is OSPF external type 2. Okay. On the other hand, I could see E1 also in here. I will tell the difference between E2 and E1 in a very short while. But please pay attention that these routes are coming from the EIGRP domain. So they are advertised into the OSPF domain as E2 OSPF routes. So my router 1, which is in OSPF domain, is aware of these networks anymore. Okay, so this is how it works really. On the other hand, if I just want to verify the routes for router 5, by the way, router 5 is the router in my EIGRP domain. Again, I'm going ahead and typing show IP route. I am seeing this time again the C route as well as one D route. D route means this route is learned via EIGRP already. That is perfectly fine since this router is already in EIGRP domain. And what is this? I am seeing something else. D and EX. EX means EIGRP external routes. Okay, those routes have been injected from OSPF domain to my EIGRP domain by using redistribution. Okay, so DEX means EIGRP external. In OSPF, the metric types for external routes are classified as type E1 and E2, and they affect how external routes are treated and evaluated within the OSPF domain. So, E1 is type 1 external metric, and the external metric is calculated by adding the OSPF internal cost to the external metric. So for example, an E1 metric, let me note in here, E1 is internal OSPF cost plus external metric. Okay, so OSPF calculates the total cost of the route to an external destination considering both internal OSPF cost and the external cost. So this allows OSPF to integrate external routes more seamlessly with internal routing decisions. So for example, if the internal cost is 10 and the external cost is 20, E1 metric would be 30. Okay, I also have the E2 routes. So E2 routes, the external metric here is not affected by the OSPF internal cost. It remains as the external cost alone. So E2 metric, on the other hand, let's type in here, E2 metric equals to external metric only. Okay, so here the OSPF uses the external metric as is without considering the internal OSPF path cost. Okay, so if the external cost is 20, the metric E2 remains 20 regardless of the internal OSPF cost. Alright guys, we are coming to end of this redistribution session as well. Thank you so much for joining me. So if there are some questions in your mind still related to the redistribution, don't worry, we will have 2 great lab sessions for the redistribution and everything should be okay after those. Thank you so much for joining me and let's see in later sections.